Hello and welcome back to compiler programming. Now that we are done with the ability to get a pointer to a particular location in memory, we are ready to take on the next step in supporting x64 calling convention on Windows, namely the ability to return a value that is larger than 64 bits. So if we look at these paragraphs, we can ignore for now the whole thing about XMM and M128. We don't have SIMD support, and we don't even do floats or doubles, which is something else that we need to take care of at some point. But user-defined types that are larger than 64 bits that do not fit into the ArrayX register, they will be passed or they'll be returned on a stack. And essentially it is the responsibility of the caller to reserve that location on the stack for the return value, and the callee will use that space and fill it in with all the stuff that is necessary. So if we look at how this works, right? So this is an example of returning a struct that does not fit into 64 bits, and it says that caller allocates memory for a struct one return and passes a pointer in RCX register, and then we basically have to shift the rest of the registers accordingly, right? So like the return value becomes the first argument kind of, and then we shift the rest. This is a bit awkward, and it might require us to do some things, some refactoring our code, but we can do it. I've also opened Compiler Explorer so we can see how that looks like, and this is exactly what happens, right? So here we reserve space including for this struct, which is 16 bytes, I believe. So long should be 64 bits, and for clarity I could also include std int.h and replace this with int 64t and this one as well. This just kind of shows that this is larger than 64 bits because it has two of them. And as you see here, as we just read in the MSDN article, we load the location on the stack for this for the return value into RCX, and we call tests with it. And then here we use this. So this is just saving RCX. We are not really interested in that. We are not really interested in this stuff. But here it this is also not I guess I should run optimized code so that it looks more like what it should be. Yeah, but now it does vector instructions. So yeah, unfortunately it's not really easy to see the part that we want to have from the part that we don't want to have. And if you're wondering what the hell this GS minus flag is, basically, if I don't do that, then it checks for, I guess, so these are security checks for buffer overflow, and they kind of obscure the code that we are doing. Eventually, we would want to have something like this as well, but like right now, we are not looking at it. Okay, getting back to this stuff. So RCX, it is now in RSP plus 8, and yeah, it puts it at, it creates basically two temporary values, one after another, and then it puts it loads the address stored in RSP, I guess. It yes, it loads the stack pointer into array-x, then it moves into RDI. Does some interesting things, to be honest. So this is just restoring the stack. This is returning stuff. Okay, so yeah. Basically, the way that works is it loads a target into RSP. It loads this. Sorry, this is a source. This is a target, and then moves it into another register. So this is just a problem of an optimized code. And then it says that we want to move 16 bytes, and then it calls this rep move sb, which is like string instructions, which allow you to essentially repeat an instruction for this amount of times. So we do move sb 16 times, and this because this is 16 bytes here. But honestly, we probably don't need to do it quite this way. We can write slightly different code which just gets a pointer and treats it as a pointer. I mean, it's not. I think it will be okay if we do it in that way. Okay. Good. Let's start working on this. I guess I will need a function. No, don't open it up. Open it here. And we will need a function spec. We already have a bunch of tests that deal with arguments. So now we will need to have a test that deals with this. Now, we will run into an issue that... No, actually, no, this is fine. Let's basically write sort of almost exactly what we have here. For that, we will need a struct, which we have somewhere around here. Struct builder, here you are. So let's just take this stuff and start working on this. Say 8 should support returning large structs larger than 64 bits on the stack. Okay. So let's create such a struct. We will have x and y that are 64 bits. Again, this is exactly what we have here. And now we want to have a function that will deal with this stuff. Again, there are two parts. One part is like us being able to call C functions that do this. And the other one is us inside the function being able to refer, like to actually do that return of the value to the outside world. And I guess today I will only do one of them, which will be the part where we want to call a C function that will return to us something by value. Because the other thing where we handle this is not necessarily required. Like, we could decide to implement this sort of stuff differently, and it would only matter in cases where like some C API would have a callback, and that callback would expect to return a value by like a big value on a stack, which is like, I don't even think I saw any videos or like API that does that. So it's just a very weird situation where we would require something like that. So for now, I'll just focus on us being able to call a C API that returns something on the stack. For that, we would need to basically add this to the tests. Let me bookmark this stuff. Oh, I don't actually need this one, and I will need to add this stuff here to us. Okay, so we say 42 and 84, right? And then we want to have a function that will do something about that. Now, we will need to create a descriptor for this function manually, because our parsing code right now does not support dealing with structs, or even more so structs that are larger than 64 bits. So let's just create this stuff ourselves. Say value overload star test, or C test function. Overload is what? Well, the descriptor of it would be C test function descriptor star is this thing. So we first allocate it as usual, then we fill it in. We fill it in with stuff. So first we of course need to say that the type of this is descriptor type function. Now I need to check what does the function actually need. For that I can, no Visual Studio, thank you. For that I will need this file. And here I can see that our descriptor function has this stuff, which we can just copy. Say function is like so. Okay, so it needs an argument list, it needs an argument count, and it needs a return value, and it has bool frozen. And frozen is just something I introduced between the episodes to track that the function is not modified after it has been called. Just a debug thing. Okay, so for the argument list, it's very easy. It is 0 or null. Argument count is also null or 0. And returns is the interesting one, because that actually is our struct, right? So let's create a value overload for the return. Okay. Return overload is value overload of this. We need a descriptor. We have that because this is going to be our descriptor right over here. And then we need an operand, and operand for this is quite interesting. Because on one hand, we will like operand will be on a stack, right? So when the function returns, the result of it will be there. That means I need to look at how we are dealing with more than 5 operands already and just deal with it the same way, right? So when we have more than 4 operands and we need to reserve the stack, this is what happens. So I guess I will need to do the same. Yeah, this part is probably gonna have to change a bit or not. Let me think about this. Who will be responsible for taking care of this? I guess when we call a function, so when we do this stuff, here is where we do stack reservation, and this stuff will need to be changed as well when we also pass big things to as arguments. But for now, we are focusing on return value, and I guess for the return value, we will need to increase this stuff, I guess. So let me just mark it for now as a thing that we need to take care of and go back to here and here. I will have to say that operand is going to be what? It's going to be stack. And let me try to figure out what is the right offset for the return. Actually, the return is sent as an RCX to the thing. So we basically can reserve any memory that we want and just use that as and put that in an RCX register. Okay, I guess that is fine. How would that look like here? So that means that whoever actually calls a function will need to do this. So operand will be type operand type what is it, memory indirect, right? Because when I'm talking about return here, we are treating it as on the side of the caller, not on the side of the body of the function. And then indirect will be what? So I guess we have to reserve the space on the stack when we call this. Yeah, I think our whole setup here might have to change quite a bit once we do this. Let's just push on, say reg is RSP and displacement is, well, who knows what the displacement is. In here, it just puts it at the very bottom of RSP. Well, I guess that's what we will do as well. This seems pretty logical. So maybe that is even okay if we do it that way. Okay, so this would be the return value. And now we need to do what? Well, first of all, this also should be temp allocate. Like so. So the descriptor is c test function overload or function. This should be descriptor. Okay, like so. Operand is gonna be immediate 64. So we just do like this. We say that type is operand type immediate 64 and im64 is s64 of well, test, right? This is what we called the function, I believe. Yeah, it's just called test. Okay, so this is the overloads that we are gonna deal with. And now we are ready to write our client code, which is equivalent to this stuff. All right, so we say function checker value is what? We say like in general, it should look like this. Return, call. So we need also value star c test function value is single overload value of this. So we call this thing. We don't have any arguments, so this is also would be a stress test for our call stuff, which actually will fail now that I'm thinking about it, which is kind of unfortunate. Yeah, so when we implemented call, we didn't really think about that very well. I guess I will have to go back to using call function value for this. And the reason it will fail is because you can't create an array of 0 items. Like I think that's just not a thing that you can do in C. So yeah, unfortunate, but something we can address later. And just in case you're wondering, the way you address this is usually you add a dummy element at the start or the end, and then probably is better, and that element, and you just remove that argument from the count, and you waste a bit of memory, but your macro always works. Okay. So call function value, c test, blah, 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 blah. This looks like this. I at least believe so. And let's separate this slightly so it is easier to deal with. We say value star test result is this. And then we need to get a field of the struct. Yes, now we have this very nice struct get field stuff. So value star x is like so. And we return x. So let's see how many errors I have made while typing all of this in. Probably a bunch. So let's just go one by one. Struct builder, it has no idea what struct builder is because it is defined in a different file, which is a bit awkward. So for now, I'll just move this whole test in different space. I will put it over here. Okay. And now we can start tackling this one by one. This is obviously not correct. It should be returns is return overload. Okay, that helps. To do this. No, that doesn't matter. Okay, C test function overload. Okay, yeah, should be like this. That's good. Here it is correct, except now it needs value overload here. That's good. Dun, dun, dun. Operand type. Did I mess that up? No, it's called indirect. Should I just do the immediate 64 of S64 of test? This might be better. Test undeclared identifier. Yeah. Now the problem is I moved the test, but I did not move the supporting code, which is this stuff. Okay, so let's move the supporting code as well. Okay. Cannot convert from const operand to register. I guess it's like this. Okay, so we are done with all of the stuff to compile, but obviously that does not work and it will not at all do what we actually wanted to do. So this is the next thing on the agenda then. Now we need to make function call actually do whatever we want it to do. And I guess I will add a fix me and say support this with additional with for functions that accept arguments. Because what I will do right now is I will just say, okay, our CX is taken and go away if you thought that you could use it for the first argument. But we also need to change the stack size, and in particular, we need to have this if and say if descriptor returns descriptor. So if descriptor byte size of this stuff is more than 8, then what we do is we say that parameters stack size is plus equals whatever this is. So let's call it U32 return size. return size, and here return size. Okay, so we need to reserve extra stack space when we do this. And the other thing that we need to do is load the offset for this space into an RCX register. How would that look like? I guess we'll need to do it manually. No, we already specified it inside of return. So now we just do pointer to. So yeah, which is what we implemented in the last video. So let's just do it this way. Value star return pointer is what? Return pointer is value pointer to, and we might actually need to, yeah, we will need to slightly bump this up. Let's have this now. Okay, value pointer to, good. Where I was right here. Value pointer to single overload value descriptor returns. Okay, so now we have a pointer, and that pointer, yeah, it's stored somewhere, it doesn't really matter. And we move that pointer to RCX, which is where it's expected by the function we call, or callee. Okay, so move value, builder return, or actually it's gonna be maybe get a single overload return pointer, but this is the source, and the target is well, we need to create a target for it, and target will be value overload star reg C, and sure, I think this is how we call them, and would be this it's register, I forgot how, value register for descriptor. This is what we want. So let's just change this. It's not gonna be A, it's gonna be C. Register C instead of result descriptor. It will now get. So let's just actually do it this way. Put a bit more layers on an onion. It's a bit annoying that we have to wrap and then unwrap again, but oh well, we can survive that for now. So return pointer overload, and here will be descriptor. So we want to have a descriptor for C register that is has the size of the pointer. This is what we're saying here. And now we are moving that pointer into that register. Again, this is all very inefficient, because what we could have done is we could have just loaded it directly, which may be something we want to do. Let me think. I guess it might be actually simpler in this case. Okay, let's just do that. It's fine. So we'll do it slightly differently then. We say descriptor star return pointer. Descriptor is descriptor pointer to for this stuff. Okay, then we have this descriptor here, and instead of move, we just do lia instruction directly, and we say reg-c operand, and we are loading from this stuff, descriptor returns operand. Okay, so that looks actually nicer and reasonable to me. Again, the comment still stands, so we are not taking care of other arguments, I believe, at least. And all of this stuff is slightly shaky. I'm not exactly certain what's supposed to happen with the stack reservation, but this stuff also doesn't say, so I guess I'll have to just dive into Compiler Explorer and watch what happens, or try to read the source of LVM or something like this. I don't know. Anyhow, let's see what is happening. I made a bunch of mistakes, most of which are typos, I guess. Left of returns must point to struct union. What is it called? Descriptor function is descriptor, yeah. So what is the issue? Okay, these are just typos. This is easy. And here it's also actually a typo. Okay, I really like to say descriptor for some reason. Happens to me all the time. Cool. We are at the point where I would be ready to fire up the debugger and see what is going to happen. Now we need to change back our target again, because well, this thing decides that it's fine. I think it's called mess. I'm not certain about that. No, just ignore. Okay, this is our fancy function, and we actually don't yet call it, so which is fine actually. So let's just start with not calling it and see that our encoding actually makes sense to everybody involved, because it might not. Okay, so we have our first assertion, and that assertion happens where? Function value, that's fine. Function overload, return single overload value. Yeah, it's actually this thing that is problematic, I guess. Oh, wait. Why are we doing that exactly? So here, once we call a function, we put the result of it on a stack. Yeah, I guess, yeah, it makes sense because we don't want to take up the arrayx register for whatever else comes after it. Okay. Then we need to do this here as well. So if return size is less equal 8, because if the return is more than 8, then we are already storing it on the stack, so we don't really care, like we don't need this to save this register. So if this is like this, then like this, otherwise it's gonna be single overload value of descriptor returns. Okay, that's fine. Let's see if there are any more issues. Okay, there are not, so at least the encoding produced something. We still have to see if that something makes any sense at all, but that's okay. So now we have function that returns S64, right? Because we are just returning one of the struct fields from that function. And here we need to do 64 as well. And the rest seems fine. It still builds. No. We can go over to here and add a breakpoint and see what is going on. Let's step inside. Okay, we reserve stack. 38 sounds sort of reasonable to me, I guess. That's fine. Then we load that memory into RCX, then we call the function and wait, which function are we calling exactly? Yeah, okay, that's fine. Now we want to move whatever is in RSP, so let's just check RSP, and we need to turn it into so it's going to be a point star RSP. Identifier point is undefined. Well, that's unfortunate. Long. Okay. So it seems that we have correcting there. So we now need to check in arrayx. Arrayx has the correct thing of 42. And we are jumping to here, which is this, and we are doing return. Good. So that actually shows to me that I think we haven't actually messed up. We have code 0 as exit, and we can rerun the tests, and everything is a-okay. And we have should support journey struct larger than 64 bits on the stack, which is what I wanted to do for today. We now have it working. So I say big thank you if you have watched this far, and hopefully see you next time.